We're going to talk about complex numbers. Now, you've heard us talk about real numbers, and everyone always wonders, are there fake numbers? Well, there are imaginary numbers. Imaginary numbers are represented by I. I stands for the square root of -1. So whenever we had, say, the square root of, -4, we was like, oh, we can't do that. It's not a real number. Well, now we have a way to write that, and we'll write 2i, because -4 is -1 times 4. The square root of -1 is I. The square root of 4 is 2. So let's look at these i's for just a minute. Anything to the 0 power is always 1. And then I to the first is just I, which we learned just a second ago was the square root of -1. I squared. So imagine I take the square root of -1 and square it. Well, what happens when you square a square root? You just get the number inside. I squared is -1. Guys, that's probably the most important fact on this page right now. I squared is -1. So I to the third. So if I take I times I squared, that's I to the third. Well, I squared is -1 times I is -I. So if you understand these first four, the pattern just repeats. I to the fourth is 1. I to the fifth is I. I to the sixth is -1. I to the seventh is -I. Here's what you do. You take your power and you divide it by 4. So on this one, 8 divided by 4 leaves you no remainder. No remainder means 0. So it's I to the 0. I to the ninth. If you take 9 divided by 4, you get a remainder of 1. So that's I to the first. So let's take a look at these. I to the 51. All right, if I do 51 divided by 4, it doesn't really matter what it is. It just matters what the remainder would be. So if you're thinking, well, I know 4 goes into 48 evenly, and that's 3 higher. So that would be a remainder 3. So I to the 51 is equal to I to the third, which is -I. 82 divided by 4. Whoops, 82. Well, I know 80 divided by 4 goes in evenly. So now I've got a remainder 2. So I to the 82 is equal to I squared, which is -1. So you just divide by 4 and take the remainder. 37 divided by 4. Well, I know that's 1 bigger than 36, so remainder 1. So that's I to the first. 72 divided by 4. I think that one goes in evenly. So that's I to the 0, because there was no remainder 0, which is 1. So if you know that top row, everything else, it just keeps cycling through every divisible by 4. All right, let's simplify some radicals now. We learned in Algebra 1 to simplify the square root of 20. I like the buddy system, so I say 20 is 4 times 5, 4 is 2 times 2, 2's got a buddy, so he's going outside. But this was -20, so let's take into account the -1. Well, we learned that the square root of -1 is I, so this one's going to be 2i root 5, the square root of -20. If it was just the square root of 20, we'd say 2 root 5. But now that we've added the -20, it's 2i root 5. Let's do the same thing with 75. 75 is 25 times 3. Notice I took out -1 because I know that's a negative. 25 is 5 times 5. 5's got a buddy. It's going out with the -1. 5i root 3. Square root of -4. Oh, I mentioned this earlier. I know the square root of 4 is 2, and the square root of -1 is I. And there's my answer. Square root of negative, it's 2 times the square root of negative 54. So negative 54 is going to be 1 times, I don't know, is that 9 times 6? And 9 is 3 times 3. So 3i are going outside with the 2 that's already there. So that's going to become 6i root 6. All right, so our imaginary numbers, complex numbers, are written in the form of a plus bi. The imaginary part is the bi, and the real part is the a. So let's solve some problems where we have to use these. First, we're going to practice simplifying expressions. So I is not a variable, but we're going to treat it kind of like a variable when we solve these. So this one, notice it's a subtraction. When you have a subtraction sign in front of a parentheses, you're going to need to distribute. So this one is 3 plus 2i, distribute your negative, minus 1 plus 6i. And we'll just combine like terms. 3 minus 1 is 2. And 2i plus 6i is 8i. On the next one, there's no distributing. There's just finding the like terms. So I have a 4i and a plus I. So I'm going to combine those to get 5i. Now I've got a plus 3, a minus 6, and a minus 1. So let's combine those. 3 minus 6 is negative 3, minus 1 is negative 4. Now, could you have written 5i minus 4? Yes. But as we showed you on the previous page, the common way to write this is a plus bi. So you'll see that more often. This one also requires distributing, and then we'll combine our like terms. So first, I'll distribute my 3, and I'll get 12 plus 21i. Now I'm going to distribute my negative 1, and that'll make that negative 2i, and that becomes a plus 10. I lined them up to make it easy to add together. 22 plus 19i. So adding and subtracting is just finding your like terms. Now, multiplication, okay, very similar to what we've done before. We're going to start with the distributive property. 5i distributed into 3 minus 2i. So 5i times 3 is 15i, and 5i times negative 2i is negative 10i squared. Now remember earlier we told you I squared is equal to negative 1. So minus 10i squared is really plus 10. Negative 10 times negative 1 is positive 10. And if you want to write that as 10 plus 15i, you can, just keeping our constant in the front and our imaginary part in the back. So remember, I squared is negative 1. That's the most important thing from the first page. All right, on this one, we're going to FOIL or double distribute, as your teacher might have called it. We'll start with the 5. 5 times 2 is 10. 5 times negative 3i is negative 15i. Now we'll distribute the positive 3i. 3i times 2 is 6i. And 3i times negative 3i is negative 9i squared. So our like terms here are negative 15i plus 6i should be negative 9i. And right here, remember I squared is negative 1, so negative 9i squared becomes a positive 9. So I'm going to put that over here and say 19 minus 9i. This one's interesting. 3 plus 2i, 3 minus 2i. Let's see what happens. 3 times 3 is 9. 3 times negative 2i is negative 6i. 2i times 3 is positive 6i. And 2i times negative 2i is negative 4i squared. Now look what happens in the middle. Negative 6i plus 6i, they cancel. And negative 4i squared is really plus 4. Because remember, I squared is negative 1. So this answer is 13. When I multiplied those two imaginaries together, I got those two complex numbers. I got just a 13. All right, I want to change this last one to say 1 minus 3i squared, because this is a common error that I see. When you square a binomial, you do not distribute the power. That's not how this works. You have to write it twice and do your FOIL or your double distributing. If you don't write it twice and FOIL, you will lose a middle term in here and have the wrong answer. So if I do this, 1 times 1, and then 1 times negative 3i, and now distribute the negative 3i. Negative 3i times 1, and negative 3i times negative 3i is positive 9i squared. Now, the like terms in the middle, negative 3i minus 3i is negative 6i. But let's look at this 9i squared. Remember, I squared is negative 1. So this really is a negative 9. So 1 plus negative 9 is negative 8. So remember, I squared is really negative 1. Be careful on those squaring your binomials. All right, the next piece, we're going to talk about a complex conjugate. The complex conjugate of a complex number a plus bi is a minus bi. Notice the only thing that changed was the sign in the middle. So 7 plus I, the conjugate would be 7 minus I. Negative 5 minus 3i would become negative 5 plus 3i. Notice the first number didn't change, only the sign in the middle. The conjugate of 12 plus 11i would be 12 minus 11i. And the conjugate of negative 4i would just be positive 4i. We needed to know that about the complex conjugate because it's going to come in handy here. Rewrite the quotient without a complex number in the denominator. So the way we've talked before in probably algebra about not having a square root on the denominator. Well, I represents a square root, so we need to get it out of the denominator. The way to do that is to multiply the numerator and denominator by the same number. In this case, it's going to be the conjugate of the denominator. So you take whatever your denominator was and multiply the numerator and denominator both by the conjugate. So this is going to take a little bit of work. We're going to distribute on the top. 2 times 3, 2 times negative 2i, negative I times 3, and negative I times negative 2i. Okay, just work carefully. And then on your denominator, 3 times 3 is 9. 3 times negative 2i is negative 6i, positive 6i, and then negative 4i squared. So notice on your denominator, this negative 6i plus 6i cancels out. The conjugate will always cancel out the middle, kind of like a difference of squares where the middle canceled out. And then minus 4i squared is actually plus 4. So my new denominator is just going to be 9 plus 4, which is 13. My numerator, I've got my like terms, 4i or negative 4i and negative 3i. That's going to give me negative 7i. And then remember, plus 2i squared is really equal to negative 2, because 2 times negative 1 is negative 2. And 6 minus 2 is 4. And that's how we simplify our fractions that have a complex number on the denominator. Let's do another one. Complex conjugate, 2 plus 3i. 2 plus 3i. You must do the same number on the numerator and the denominator because we're actually multiplying by 1 when we put the same number on the top and bottom. All right, let's do some distributing. 3 times 2, 3 times 3i. Negative 4i times 2, negative 4i times 3i. And my denominator, 4 plus 6i minus 6i minus 9i squared. So we kind of knew this was going to happen. Those cancel. And negative 9i squared, remember I squared is negative 1, so that's actually a plus 9. So my denominator is 13 again. 4 plus 9. My numerator, I have my like terms. 9i minus 8i is just 1i. And you, of course, don't have to put a 1 there, but if you do, it's not wrong. Negative 12i squared is really positive 12. So 6 plus 12 is 18. And there we have it. If you would like to practice the next two, then you can pause the video. And when you turn it back on, I'll have these solved. So there we have the last two solved. Something I want to point out about this last one is when I got my final answer, I noticed I had 60 plus 70i over 20. And I thought, hey, those are all divisible by 10. So I divided by 10. You can only do that if every single term is divisible by 10. Some might look at it this way. If I took the top and factored out a 10, then on the bottom we could also factor out a 10. And that's essentially what we did, divided the numerator and denominator by 10.